Hello there, welcome to another lesson on Clinton Virtual Academy. We are going to be looking at electricity and electronics. Basically the components of an electronic circuit. Okay, so in our previous classes we have learned that for electricity to do any work, it needs to be able to move through some material. One of the materials electricity can move through is a wire. When you connect a wire to a battery, electricity flows. Electricity will flow through the wire, and this makes the appliances work. If you want to know if electricity moves through a wire, you can perform an activity using a battery, a bulb, or LED, and a switch. So when you look at the diagram above, you can see that we've constructed a simple electronic circuit which consists of a bulb, a switch, a battery, and then wire. Now, electronic circuit is a way or path through which electricity can flow. Okay, so it flows through an electronic circuit, and it's called the electricity that flows through an electronic circuit is called electric current, right? Okay, so an electronic circuit has components or parts that make the circuit work. For every component, the part includes one, a wire. So the connecting wires connect the various parts used in the circuit together, and it allows the flow of current. Okay, so a wire is made from copper metal, but it's always covered with a plastic material. The plastic material prevents us from getting shocked by the current flowing through the copper. Another one is the battery and bulb. So the battery is a part of the circuit that provides electrical energy to the circuit. Okay, and the bulb gives the light when the current flows through the circuit. The switch is a device used to control the circuit. The switch can also be called key. If you want the circuit to go off or stay on, you use the switch or the key. When the switch is open, the current does not flow, and when we say switch is open, it means switched off. When we say the switch is open, it means we have switched off the circuit, and when the switch is closed, it means we have switched on the circuit, and when it's closed, electric current can flow through the circuit. There is also light emitting diode or LED. This is a device that gives light when electricity passes through the circuit. It is not the same as bulb, though. LED uses small amounts of electricity. Now, all these components that we are talking about in the circuit, they all have their individual symbols. So we are going to be looking at these symbols that are used in representing the component in a circuit diagram. So when you look at the bulb, the 8 symbol is beneath it. The symbol of the bulb is beneath it. The switch has its own symbol. The bulb has its own symbol. The wire has its symbol, which is just a line. And the diode also, the LED also has its symbol. So circuit diagrams are used to represent the arrangement of cells, resistors, and other electrical components connected together. So you can see the component and their symbols down here. Now, to be able to draw an electrical circuit, you need to use diagrams to represent various components. Before we learn how to draw a circuit diagram, let's look at what is closed and open system. So if you look at the diagram on my right, you see that there is a bulb, there is a battery, there is a wire. If you remember the symbol for wire, there's a wire, and then there is a switch. So the switch is down, the bulb is up, the battery is to my left, and then the switch is below the bulb. Now you can see that in one of the switch is the part of it is raised up, and the other one, all the parts are down. In the one that has a part raised up, we call that one open circuit. Open circuit. So once we open the circuit, there is no flow of current, so the bulb is not on, it's not lighted. And in the closed circuit, because the circuit is closed, current is flowing through the wire and the battery, so the bulb is lighted. Basically, this is all that is there to know about open and closed circuit. Okay, this is all that the open and closed circuit means. Now let's look at the different way we can connect circuits. There are two ways we can connect a simple circuit. These are series connection and parallel connection. So in parallel connection, the various components in the circuit are not connected end to end in the same line to form a single path. A parallel circuit has two or more paths for the flow of electricity. The components are parallel to each other with different currents flowing through them. So if you look at some examples of circuits connected in parallel, so in the example there, you can see that they are connected. The connection is done in parallel, and there are more than one path for the transfer or the flow of electricity. In series connection, the various components of the circuit are connected end to end. Okay, so from this battery or from this bulb, it goes to this one. From this one, it goes. So they all it's like there is one line and they are all on that line. Okay, there is one line and all the components are on that very line. There is no branch anywhere. Okay, that is basically what the series connection is all about. So here the same current flows through all the components in the connection. So when you look at the diagram there, you will see what I'm talking about. Now let's look at conductors, semiconductors, and insulators. So there are many materials that allow current to pass through them very easily. Others do not allow current to pass through them, and there are others that only allow electricity to pass through them partially, like not completely. Okay, sometimes it will allow, sometimes it won't allow. All right, so materials are classified into conductors, insulators, and semiconductors according to how they conduct electricity. So for those materials that allow current to pass through them easily are known as conductors. So example of conductors are copper, iron, and aluminium. And you know that do you know how the bulbs in our homes are lighted? Conductor is always required to transfer electricity from one point to another. From one point, which is the switch, to another, which is the bulb. Okay. Now those materials that do not allow current to pass through them are called the insulators. Now another name for insulators are bad conductors. So another name for insulators are bad conductors. Example of such insulators are the papers, stones, wood, rubber, plastics, or glasses. Electrical wire is in our homes are coated with plastic because plastics are insulators. Do you know that? So they don't allow current to flow through them. In that sense, we are not going to get electrocuted by the wires in our homes. However, there are some materials that are neither conductors nor insulators. They have properties of both conductors and insulators, and these are known as semiconductors. Example is silicon and germanium. Okay, they are examples of semiconductors. Okay, so that's the end of the lesson on electricity and electronics. I hope you've gained some insight on the electronics and electricity that we've been using at home. I'll bring you another lesson soon, so do stay with us. Until then, bye.